And hello everybody, this is Essence of Zen Videos, bringing you the next installment of our Python 101. This is episode 2. I know it's been a few months because the last video for Python 101 was back in October, and I apologize. I've been buried in a lot of schoolwork, but as you know from previous videos, if you haven't watched, I am now out for the summer. Good news, I passed all my classes, all A's and B's, but now that I'm out for the summer, we're going to get back to doing what we do, which is providing you with simple tutorials on how to program, and this particular video is based on Python. So in our previous video, which I will link in the description below, as well as leave an annotation, either I think onto the right, because I'm experimenting with this new hexagon background, as you've probably seen. I'm sorry, it doesn't really look all that well right now, but I'm testing and I'm improving, and that's what we do here at EOZ. Also, Lewis, aka that Mexican with AK, is back at home right now. He's relaxing, and he'll be back next week, and we will have our live YouTube discussions yet again. And in the meantime, let's go ahead and get programming. Now, I was supposed to say what we covered last time. We covered last time in episode 1 basically about the types of variables, and I told you that we're going to get into using those type of variables and a better understanding of forms like addition, subtraction, multiplication, division, exponential, functions. And if we have time, which we should, because I know how to do this already, and I've pretty much worked a way to cram it all in easy steps, we're going to get into if statements and digital logic. Alright, I'm sorry if you hear any like bleep bloop blops. I have Facebook up because people love messaging me with various things. So anyway, let's get to it. Now, we want to do simple addition. So you can do this in the console, the Python. I call it the IDE/console for Python because that's kind of what it is. We're gonna go ahead and do like 3 plus 3. And that gives you 6, and you can even run this with 3 plus. No, wait, you can't. You gotta do print 3 plus 3. This should work. Excuse me. We're gonna save this as. We're gonna go ahead and make a testing folder. Okay. Testing. Oh, you guys can't see. And we're gonna name this test.py. In the previous video, remember I told you about the .py. This is important. Yeah. We're gonna do that, and we're gonna go ahead and run that sucker. And as you see, it works. Now, basically, since I'm pretty sure you can already tell what's happening. You have your A and you have your B. We're just keeping this simple. So you have 3, and we're going to use the plus sign for our addition, and we're going to have 3, and when we printed that out, it gave us 6. Now, when programming, excuse me here, when you're programming, you may think, well, this is super simple, but we're gonna build on top of this simpler logic, okay? So let's go ahead and make this a little more complicated. We're gonna have a variable named A, and we're gonna give it like 10, and then we're gonna have a variable B, and we're gonna give it like 2, and then we're gonna say A and B. I'm pretty sure you guys can guess what this is gonna give you. Go ahead and guess right now, and then just scream out loud what it's gonna be. I can totally hear you, even though you're gonna watch this video afterwards. Press F5, and it gives us 12. That's awesome. Now, let's go ahead and give a little more difference, and I'm gonna go ahead and turn the beeping off. Excuse me. Chat sounds off. Thank you. We're gonna give this 10.4. Now, can you guys guess what this is gonna print out? Go ahead, scream it out, guess it out. Are you absolutely sure you got the right answer? Boom, 12.4. Yes. Now, let's go ahead and how do I put this? I forget. Simply put, if you're gonna have a float and a int, and you add them together, it's gonna give you a float. That's just what it does, because a float simply kind of overrides the int. And in some cases, which I'll probably show in a later video, you may have a float and you may have a int, and when you ask for a certain outcome, like in a function, let's say, it may return to you a simple int. And that's probably because you didn't tell it to make it a float. That's weird, and I'm pretty sure in Python 2.7 or below, like 2.1 and whatnot, that wasn't always the case, and you always have to specify by adding like a 0.0. And for the record, that is always best to do, just simply because you want to tell it, I'm doing something by a float. Floats are more precise than ints because the floats are what gives you the decimals. Anyway, that basically covers addition. We're going to have a print here, and you could just leave that blank like this, but I always have an empty string just because, and this is going to give us a space. And we can always do, you know what? I wonder, can we do this? Addition. And then plus that. And then do that. And then do that. Let's see if we can. I gotta put this in a string, don't I? Yeah, I think. And this is what I hope to tell you. Yeah, it works. Okay. Sometimes I deviate from my script that I'm following. It's not a full script. It's just the basic over things of what I'm gonna cover. But coding on the go, even, you know, it makes yourself learn. You may not know every single thing about coding, and that's the fun thing about programming, because you can always learn new things just by doing something completely random. Anyway, let's continue. Let's go ahead and do multiplication. So we're gonna do. Do I need to explain what I'm doing here? So I'm gonna have I'm printing a string, subtraction, and I covered this in the previous video. So we're gonna go ahead and do an add-on to this string. We're gonna do string a minus, not double minus. So a minus b. And when we continue this, we're gonna go ahead and close it off yet again. So then we're gonna have our string subtraction, and then we're gonna add on another string using the variables a and b, and we're gonna do the minus symbol to subtract. And then we're simply going to do another print empty string for a space. And see, simple, right? You know, 10.4 minus 2 is 8.4. And we can go ahead and continue doing things like let's see, multiplication plus, make this into a string, a times, we're going to use the asterisk. Here's a funny word to say. One of my old professors used to call it simply bang. He used to, yeah, or is that a not sign? I think the not sign was bang, and like the slash was whack. But anyway, we're gonna do that, and then print with the double signs, and we're gonna go ahead and even do print division, and then string, and then a slash b. That's for, what do you mean? Oh, whoops. Anytime it gives you a ding, you're doing something wrong. Am I doing it right? Am I doing it right? No, you're not. Anyway, and the slash or the whack is for division. We're gonna go again and then print our empty string. Alright, then we're gonna run it. Alright, so multiplication, 10.4 times 2 is 20.8. Because 4 times 2 is 8 and 10 times 2 is 20. And then we're going to divide 10.4 by 2. We're going to get 10 divided by 2 is 5, and 4 divided by 2 is 2. Yes, I have a very regal accent now. Yes, indeed. But anyway, the really fascinating thing about Python is its built-in function for exponential function, or exponential operation. There we go, operation, that's what it is. So we're going to do exponential. I spell that right? Exponential. Yeah, I spelled it right. I'm a horrible speller. And then A, and then you're going to do double asterisk. And for you guys who do not know, exponential basically means exponents. So it's going to be A to the power of B, aka 10.4 to the power of 2. And we're going to go ahead and do that, and then again our space. And we're going to run it, and we get this weird, crazy number, because 108.1601 is what we get when we do the exponential operation. Fascinating. We're at the 11 minutes mark, and my intro is about 30 seconds, I think, or no, it's like 10 seconds or 5 seconds now. I can't remember. We're working on a new intro, by the way, but that's not important. That's not here nor there. Let's get back to the programming. Now, I told you guys, we went over the addition, subtraction, multiplication, division, and exponential operations. Let's go ahead and get into the meatier portions of the basics of programming. The logic. Programming is basically just freaking logic. The computer itself runs at a simple, it's simple, but it's a lot of simple. So basically a computer can simply only add and compare. Okay, you're saying, no, well, I can subtract, multiply, divide, and all this. No, all those are built from comparing and adding. What happens when you add a positive number to a negative number is subtraction, but you're still adding. When you compare, you can do things like multiply. So you say, I want to multiply 2 by 2, where you compare 2 and 2 within itself, and then you're basically doubling that by adding on 2 pairs of 2s, which gives you 4, or vice versa when you're doing a bigger number. So anyway, our logic is going to start off with if statements. If you're a college student and you're doing something, let's go ahead. Okay, yeah. So if A, and another statement is basically if condition A is met, or if this condition is met, then this event will happen. Else, or else, do this. So we're gonna say if A is greater than 5. This is Python. I think I can do a. If A is less than or greater than 5, print hello. I'm Mrs. Doubtfire. And from there you can do else, print I am not Mrs. Doubtfire. Get lost. I almost said another word. I do believe this is the correct. Oop, no, I think I messed up. This should be here. I do believe. Maybe. We're gonna find out soon. Yeah, hello, I'm Mrs. Doubtfire. Now, if I make A into 4.4, then it's gonna go if A is greater than 5. So it goes and pulls in A. A is 4.4. So 4.4 is not greater than 5. So we should get the else. It totally skips this line because this line is only supposed to be called when this condition is met. So let's go ahead and see what happens. Yes, save. I am not Mrs. Doubtfire. Get lost. Alright. Now, with if-else statements, you can have a world of array with like fun. And we're going to go ahead and make this back to 10.4. And then you can have else if, or elif, which stands for else if. So A is equal to oh yeah, champagne. How else do I remedy this? So let's say A is equal to 10.4. Print bam. Again, sorry about the sidebar. So basically it's saying if A is greater than 5, print this. If A minus 5 is if A is not greater than 5, excuse me, skip this line and go to this line. If A is equal to 10.4, which is redundant, so let's go ahead and say 4.4, print bam, else whatever. So we're gonna run this, once, okay? Invalid syntax. Oh, excuse me. The operation for comparison, which is if A is equal to something, is double equal marks. Because a single equal marks is saying A is equal to 4.4. A single equals marks is for assigning a variable, like we did up here. A is indeed equal to 10.4. Now if you want to compare, we say A is comparing, or is compared against 4.4. So we're gonna run that. Now we get the hello, I'm Mrs. Doubtfire, because A is greater than 5. Now let's go ahead and make A 4.4. Okay. And then we're gonna print that, and then it's gonna say BAM! Like what's his name? The guy from Futurama. The chef, the purple chef. BAM! Who's also based off another chef in real life who goes BAM! So we have a 4.4 here. So we checked it. We said if A is greater than 5, it isn't, so it skips this line. If A is equal to 4.4, we print BAM, and we did because it's 4.4. It's check. See this right here? A is equal to 4.4, so, etc. So after that, we go ahead and we can do something like 3.3. Save it. Okay, you guys guess what this is gonna print? Yeah, you already know. I am not Mrs. Doubtfire. Get lost. Because it goes, if A is greater than 5, print hello, I'm Mrs. Doubtfire. Is not greater than 5, so we skip that line. We check for elif A is equal to 4.4. We go back and we say, is A equal to 4.4? No, it's not. So then we go with our last statement, print I am not Mrs. Doubtfire. Get lost. Now, I bet you're wondering, what is the importance of an elif statement if all you need to, or all you want to do is something like this? The thing is, if you're running a loop or a continuous program that's always checking for something, you want to have the elif be the secondary condition. It's going to be hard to explain. I got to show you in a future video because we're going to go over loops. Maybe on episode 4, not episode 3, so to say, but we'll get there. Or would loops be easier than functions? We'll probably do it next episode. Alright. So now we have our if statements, and we can go ahead and do our or statement. So or statements are basically put in the middle of if statements. So we can have, let's go ahead and make some new variables, shall we? And it's always nice to have global variables, and I'll go over global variables in either episode 3 or episode 4. So let's go ahead and do like y equals 100.0 and z equals 250. Yeah, 250 is nice. Anyway, let's see. If y, let's go ahead and make a little space here so we don't get confused with our output. If A is greater than if Y is greater than Z, or if Y is greater than 90, or if Z is equal or greater than 200, print hi. Doom. Else print I was their turkey all along. Smiley face. Okay, can you guys guess what this is going to print out down here? Invalid syntax. Where? Maybe I just do that. That should work. Yes. Say hi. Doom. Because Y is greater than 90 or Z is greater than 200. Now if we go ahead and change Y to like 80 or 89, doesn't matter, it's below 90, it's still gonna do hi doom because it doesn't matter. It's an OR gate, and we can do this with digital logic, which I'm going to explain at the end of this video. We're reaching the 21-minute mark, so yeah, let's go ahead and wrap this up then. So because Y is less than 90, it doesn't matter because our Z is still greater than 200. Now if our Y was equal to 90 or something higher, like 91, then this doesn't even matter. It's not important because the condition is already met. When Y doesn't meet this condition, it crosses that out and then it goes and checks this condition, which is Z is greater than 200. If it is, boom. But if it isn't, let's say you don't like 150, gotta have that 50. It goes, I was a turkey all along. Yes, Gert, you were the turkey all along. Now, we're going to go ahead and bring up something called Logisim. I think I have it on here. Let me pause the video real quick. Okay, we're back. I had to find a program. It was on my external hard drive. So boom! This is Logisim. This is a program used for making logic circuits or logical circuits for hardware manufacturers. Okay, and you can do the same thing because hardware logic is really similar to programming logic on its basic concepts. I was a robotic major. I still fiddle with robotics as well as hardware. I'll do videos as soon as I get new equipment because I'm no longer at my previous university that had its own lab. So, I just showed you about OR gates. I can also show you AND gate. That's what I forgot to do. AND gates. My apologies, good sirs. So if Y is greater than 90, or we're gonna 90, and this is the AND gate. Z is greater than 200, so we're gonna go ahead and make this back to be 100. We're gonna make this back to be 250. We're gonna do print boom shakalaka. Yeah. Else print hi. No Superman no here. No Superman no here. And I can say that I have a Mexican friend. So, can you guys guess what this is gonna do? So basically it's saying if this condition and this condition is met. So it's gonna go boom, 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 shakalaka, because Y is greater than 90 and Z is greater than 200. Now let's say if we make this 150. What is it gonna do? Because our Y is still greater than 90, but our Z is less than 200. Can you guess? No, Superman is no way help. Because an AND gate needs both conditions to be met. It needs both. So if the first one passes, it checks for the second one. If it doesn't, it doesn't. Now, if the first one does not pass, it go ahead and go, well, I know this isn't going to be true, so go ahead and go to our second line else, because the first condition is already, you know, whatever. So to show you what I mean by this, we're going to use logicin. So we did an OR gate and we did an AND gate. So I'm going to show you, this is an AND gate for hardware, and this is kind of like a dual summary, and this is an OR gate for hardware. Now, we're going to give like an input, and we're going to give another input here, and we're going to give an output, just because I'm so different. Yeah, I'm so adorable. Yeah, that's right, you connect those pins. Alright, yeah. You like Krabby Patties. Anyway, so I'm gonna go out with a little clicky finger here. An AND gate needs both conditions. Remember, it needs to have both conditions. So if this one is met, it doesn't do anything because our other condition isn't met. 1 means it's on, 0 means it's off. So in order for this output to be on, both conditions need to be met. Imagine 1 being met, 0 means it's not met. So when both options are met, it gives you the met sign. Now with 0, with an OR gate, one of the other needs to be met. So when both are 0, you know, it's not met because it's not met and not met. But when one is the met, okay, well, I'm met. If both is met, okay, I'm still met. If this one is off, well, it's still met because it needs one or the other, or both. It doesn't really matter. If I turn this one off, it's no longer met. And that's the simple concept between AND gates and OR gates when you're doing if statements, or not if. It can be almost anything. And that basically covers everything for episode 2. If you have any questions about what we covered on this episode, please leave a comment below. If you like what you saw, leave us a thumbs up. If you want to see more, subscribe. We will be coming out with episode 3 later, maybe next week. I'm not 100% sure. I got other stuff to do. And aside from that, I'm going to drink some of my juice here. Oh yeah. Other than that, I hope you guys enjoyed. If you wanted to tweet me ideas, it's at Zenokami. We have my Google Plus account will be posted below in the comments. We have a Facebook page for EOZ. It's Essence of Zen, and we're gonna keep doing these videos. And as soon as Lewis is back, he's probably gonna do something with the Raspberry Pi, like do a basic video and using it and etc. And that's about it. Yeah, if you guys want to see more videos about hardware logic, like Logicin here, with actual gates and input output memory, multiplexers, demultiplexers, etc., let me know. And I'll probably start up some tutorials on that as well. I need to refresh my memory, and you're gonna learn about K charts, which are super annoying. You can learn about resistance, ohms, capacity, current, yeah, and voltage. So if you want to, just leave a comment below. Thank you guys for watching. Take care.